Alright, hello and welcome back to my 2D Left 4 Dead clone in Unity tutorial. Today we are basically covering having multiple unconnected sections. Oh, I say unconnected, sort of multiple sections of levels. So say like in No Mercy, you'd have like the initial apartment building you go down through, then the street, and then you finally go into the subway where it's the end of the level. I've got that represented by my whole one texture level. So we've got our like teleports, I'll link with the pathfinding, we're doing that today. And I've also got infected spawning. So basically, it'll spawn infected in places that basically the player can't see. And then it also does some what's the word? Cleanup of the spawn. So say if you made it through these sections without killing some of the infected, rather than just leaving them there, we actually just clean them up. So we destroy them, and then we reset the spawn points to let them be used again. So if the player were to backtrack through the level, they'd respawn rather than just having them be there all the time, like trying to see if they could see the player from where they were. Yeah. Now, just a quick diversion. I am on Patreon. Sorry to have to plug, but as you can see, I don't have any patrons. So a crippling caffeine addiction won't pay for itself. So by submitting $1, you get access to the project when it's done, and voting on the next one for a $5, you get access to the project files every week. So week by week, you get updated, as you can see here. And for $10, you get access to all of those other things. You get to access to the poll, like you get to ask me questions and shit, as well as in the comments, I guess. So, I just guess it'd be easier to give a response here rather than on YouTube. And what is it? You also get like Steam keys for games I release. So if you were to give me $10 a month, you get like a copy of Loud or Quiet, and then maybe the other game I'm working on down the line, like Miles. Yeah, I'm working on another game. But yeah, so back to the tutorial now because you don't want to see me plug shit. Yeah. So I'll just quickly demo this, and then we'll get on to the actual thing. Right. So let's play. So first off, we can see that the player is here and not animating, but whatever. Then they should have spawned. Why have they not spawned? Oh, Christ. Oh, there we go. We see as we get close, the infected gets spawned. Sorry. I thought the distance was more than it was. So yeah, so as we got into this building, we'll see that, what's the word? The infected spawn. And if we can just make our way through the building without actually killing anything, so we don't attract more, yeah, you can just bugger off. We can see that the infected can follow us through the level. So like, to sort of, yeah, they can follow us through the level, but I was sort of lost for the word to actually call it like 3D or something. Because like in 3D, you wouldn't need to do something like that. But yeah. And as you can see, it has despawned a load of them because we are far enough away. And I will just keep going even further. And hopefully you'll be able to see that the other ones have despawned. Yep, you can see more of them have despawned. But if we were to backtrack through the level, yeah, loads of these zombies trying to kill us. Go. We can see that they have respawned again because we had a free spawn point. And yeah, that is pretty much what we're doing today. So let's go have a look at how this all works. Okay, so first off, we have the teleports. So basically what these are just game objects in the level with a box collider that has the isTrigger attached. So basically isTrigger means it'll detect when an object is within the area that it is covering. So in this case, it's like a 2x3 square, you can see by the green line. But it won't actually push objects away like a normal collider. So yeah. We've also got our teleport script, which is linked, basically stores the teleport location that it's linked to. So in this case, it's teleport test 2. We've got teleport test 2, it's there. And that's linked to teleport test 1. You get the idea. basically just link pairs. I did assign them in the inspector rather than do it by code. So yeah, so let's go have a look at the teleport script. So first off, we got a public teleport, which is just the teleport you paired with. That's where you get moved to when you go through this teleport. We've also got a public boolean to set nodes. Basically, what we do with the teleport is we set the node neighbors. So I'll just go to this method quickly. Basically, what it does is it will get the nearest node to the teleporter, so one that's will be within it, so close to the center position of it. And it will then do that for the teleport that it's connected to, and then we'll set these nodes to be in each other's neighbors. So that will allow the actual paths to go, the AI to path find through these teleporters so they can go between different sections of the level, which is good. So we do this by using pathfinding.me.getNearestNode for this.transform.position and for the one that's near neighbor. So we get the node that is near to the one I'm paired with, .transform.position. We just set the color to be blue just to mark them out really, so we can see that it actually works. Then we get the neighbors out of the nodes that we got and add the relevant neighbor or the relevant node. So for the node that's near the first teleport, we add the one that's near the second, and for the one that's near the second, we add the one that's near the first teleport. Then we say set nodes to true. So basically, if set nodes is true, we return, basically because it's not that big of a deal. It just makes sure that once the second one I am paired with gets called in start, it won't have to do it again because we've already done it, and we don't want to add we don't want to have like identical or copies of the same node in the neighbors list, because that just make the pathfinding a lot more inefficient, and that's never good. So yeah, other methods in the teleport script are OntriggerEnter. This basically controls the teleporting. So if time since I last teleported, or last time I teleported, is more than 0.0f, we will return. Basically, we try to limit the teleporting to once every 0.1 of a second. Basically, because we're doing OntriggerEnter, if we didn't have this, as soon as the object got to the teleport, it would then call OntriggerEnter for the one I am paired with, and then get pinged back to the starting teleport, and then it just ping pong between the two, and that's not good. So by having this tiny 0.1 second gap, you could probably even get away with an even smaller number, as long as it was longer than a frame. By having this little gap in between teleports, we can basically stop that, because it will basically stop us teleporting while the OntriggerEnter is taking place. So assuming that last time I teleported is equal to 0, we set it to 1. We get the difference between the position of the object trying to go through the teleport. So in this case, Infector can go through teleports, players can go through teleports, and bullets can as well. So you could spray into a teleport to try and kill zombies that are chasing you, if you wanted to do that. We then set the object going through the teleporter to be the teleport that it's going to minus the difference. So it's kind of not getting set to the direct position, but it's sort of I think it gives it the same position relative to the new teleport. So hopefully that'll work. Yeah. So basically just try to match the position of where you were on the first teleport to where you were on the second teleport and make that look a bit better. Yeah. And also in the infected behavior, if it's an infected going through the teleport, if infected behavior can go through this nearest teleporter, then we set node closest this. So I'm just going to go through this method quickly. So we'll just right click, go to declaration. All right. So basically we've got a new variable in the infected behavior is the last teleport I went through. This is basically just to make sure that the infected don't keep pinging between two different, what's the word, teleports. That's the one. And we've got a float that just controls it. So this float counts down once we come through a teleport and sets it to 0. Sets last teleport I went through to null, I believe. Yep. So last teleport timer just basically resets that, sets it to null. And game object for my spawn, which we'll get into in a moment. But back to the can we go through teleport method? So if last teleport I went through is null, then we return true. Otherwise, if either the last teleport I went through is equal to t, or the last teleport I went through is paired with the one I just went through, then we can't go through it. So we don't want to get like pinged back and forth between the two teleports. But otherwise, if it's like a different teleport, then we return true. So if you wanted a sort of example of that, so say this, we're just going to use Zoe as an example. So say we go for the infected goes through here and goes into the teleport. They then get instantly transported to this, and the teleport, their current teleport is set to teleport 1. That basically makes sure that since teleport 1 is paired with teleport 2, which they've just arrived at, they then can't teleport back to teleport 1 until they've gone through another one or the timer has reset. So that basically just makes sure that they don't instantly get pinged back and forth between the two. Okay, hopefully that makes sense. What else? And you'll also notice that if we do get teleport the infected, we call this ib.setNode closest to this. So first off, we get a new path to the target. We set the last node teleport I went through to be t, and we call the last teleport timer to be equal to 1.5. And since we're returning, we don't actually need all this. Because, yeah. Actually, I'll get rid of it. Got it. So, yeah. So basically, once we've gone through the teleport, we just refresh the path to make sure that everything is okay for that infected. And since I didn't have it before, basically on destroy, when an infected is killed, we just call we remove it from the list of infected in world in the infected monitor. Okay, and one last thing, I promise. For the teleport manager, this is basically just a script that monitors all the teleports in the world and counts down this last time I teleported float that we had, just to make sure that we don't get ping-ponged between the two teleports. So that is why that is there. Okay, just one quick change I made to the pathfinding nodes. Sorry, not to the pathfinding nodes, to the actual how we decide what pathfinding nodes are neighbours to each other. First thing, I've changed the working out of the distance to be vector 2 rather than vector 3. I think I had to make that change. And I've also made it so the distance is basically, if the distance between the two nodes is less than 1.1 meters, then they are neighbors. And I've changed it so that if a path node is not walkable, then it can't be added as a neighbor. But at the same time, if a node is not walkable, it still gets the same neighbors anyway, just in case it starts on that, like a path starts on that node by accident. Yeah. And now we get on to the director. So it's a bit bare bones at the moment, but what this does is control the spawning of infected. So basically we've got a singleton reference to the script, game object for the infected prefab, and 2 lists of game objects. One is like the starting list of potential spawn points for zombies or infected, and the second one is spawn points that we've used, because we don't want to use a spawn point more than once, because the player would notice and it's a break immersion, so that'd be bad. Yeah, so in Awake we just set the singleton, we don't know if we're in start, so we can delete that. Then we check if should we spawn infected is true. Then we call the spawn infected method. Should we spawn infected basically just checks infected monitor dot get number of infected, and if it's less than 25, then we return true. So if we have less than 25 zombies in the world, then we spawn more. And that basically just get number infected is just a static method, so we don't need an actual instance. But basically what we do is we make sure that the singleton's declared, then we make sure the list is declared, like we did with the add infected to list, and then we return the length of the list that we had. So yeah. And for actual spawn infected, so first off we grab a spawn point, so from the infected spawns, so we use this get infected spawn method that we've written. What this does is it goes through each of the spawn points in the list and checks if the infected spawn is usable. So basically that makes sure if the sprite renderer on the infected spawn is not visible to any camera, and if the used infected spawn is not in if the infected spawn is not in the list of used infected spawns, then if either of those conditions are true, then we return false. Otherwise, we return true, saying that the spawn is good. Then we check if the spawn is null. So get infected spawn basically has. Oh no, sorry, I forgot. I'm getting ahead of myself. We've also got two other checks. So basically, we have a random check to see if it's less than 50, then we use a spawn. Otherwise, we don't. Just like a 50-50 chance that we use that spawn or not on occasion. And we also check if the point is in range of any player. So basically, we just go through all the players, and if the distance is more than 10 and less than 30, then we return true. So we could use it. Otherwise, we just return false. This basically makes sure that we're not spawning zombies in the player's view, but at the same time, we're not spawning them far enough away to see that for them to not be encountered and, to waste processing power existing. Okay. And then if all those conditions are met, we remove it from the list of infected spawns, we add it to the list of used infected spawns, and we return it. Otherwise, if one of those conditions is not, if we can't meet any of the conditions for any of the spawns, then we just return null. And finally, we create the infected at the spawn's position. We set the infected behavior's spawn to be the spawn that it was created at. So if we look at the infected behavior here, we have a new game object variable called spawn, and that is used in the infected monitor. We have this new method called infected cleanup. What this does is it basically goes through all the infected in the world and checks if the infected is in despawning range. So we pass in the infected's position, and checking if it is in despawning range, we go through each of the players, and if the actually, let me go to I should change that actually. It's wrong. So if the spawn is less than or equal to 30, turn true, turn false. Sorry, I had that the wrong way around. Basically, we go through each of the infected. I should probably change that actually to 50. Not 550. Yeah. So we go through each of the players. If the distance between any particular player and that infected is less than 50, we return false, saying, okay, that infected is not in despawning range. Otherwise, if we go through all the players and the infected is more than 50 away, because the players are likely to be clumped together because it's a co-op shooter, then we return true, saying, all right, we don't need that infected anymore. The chance of the NPC actually encountering them, or the player actually encountering them, is slim to nil, so it's no longer needed. So yeah. And so if that condition is true, we call reset spawn. So what it does is it takes the infected spawn out of the used infected spawns and adds it to the infected spawn list again, so that if the player were to backtrack to the location, an infected could be spawned there again, making it seem like the infected weren't destroyed, but they were, just to hide it a bit. Yeah, and then we destroy the infected behavior.game object, and since we added onDestroy to the actual infected behavior script, here it automatically removes the infected behavior instance from the list of infected in the world, which would then allow the director to spawn more infected. And that is pretty much it for the infected spawning. I hope that wasn't too rushed, or I hope that made sense. But yeah, it's a quick demo again. So just click play. Wait for it to load. Alright, so as you can see, we've got no zombies in the world because we're not close enough to spawn any of them. So let's go. Now we're in this bit of a level. We're close to spawn, so we can see that the infected have been spawned. Let's go through this level. We'll see that they follow us. Just lead them through here, and we can see that we can go through teleports to different sections of a level, and infected will follow us. And yeah, see that they're following us still. And we can go through around here, and we can notice that some infected still exist in this section of the level we've gone through, but at the same time we can, as we move further away, they have been despawned. But if we go back to them in a moment, just give us a minute. You're never gonna catch me. Go back to that section of the level. Where are we? Over here. It has respawned them again, just to sort of save performance and like have the infected there, so we could have technically more infected, or the appearance of more infected, while actually having less infected in the level, if that makes sense. So yeah. So cheers for watching this first part on the section of levels. This might be a couple of episodes because I know we've got to do like level transitions between like safe rooms and shit. We've got to do item spawning and events and shit like hordes. So you know that'll all come in time. But in the meantime, I've been Unit 02 Games. Cheers for watching. If you liked what you watched, or you want to support me, even there's a Patreon. And you can buy my assets for previous projects on the itch.io if you don't feel like making a recurring donation. You also get stuff for pledging on Patreon, like I said at the start of the video. My game Loud or Quiet is out on Steam. It's really good. You should buy it. If you have any questions and stuff about this project or anything, feel free to ask in the comments. And yeah, cheers for watching and goodbye.